If you're a developer, you know this feeling. You're staring at your code and you're wondering, is a simple function enough for this, or do I need to build a whole class? It's a choice that can seriously make or break a project. So let's break it down and build a simple framework to help you get that decision right every single time.
So, yeah, this is the big question, right? Are we just trying to perform an action, or are we trying to model a concept? Look, it's not about which tool is better, it's about which one is the right tool for the specific job you're doing. If you get it right, your code is clean, it's maintainable. But if you get it wrong, well, you're on the fast track to a tangled mess. At the most basic level, we're really just dealing with two things. On one side, you've got behavior, the actions, right? The verbs of our program. That's a perfect job for a simple function. And on the other side, we have our data, the nouns, the actual information we're storing. And Python gives us amazing tools for that, like lists and dictionaries. But what happens when those two worlds, the world of data and the world of behavior, can't really be separated? What happens when they are fundamentally linked? Answering that one question is what reveals the core principle behind knowing when to go object-oriented. And here it is, the aha moment. When the data and the behavior that acts on that data are equally important, you bundle them together. And that bundle, well, that's an object. This simple little equation is the absolute heart of all object-oriented thinking.
So what is an object really? It's not just a fancy container for data. It's a complete model of a concept. I mean, think about a user object, for instance. It's got data, right? Like a username and an email, but it also has behaviors like login or change password. You can't really have one without the other. That's what makes it a user in the first place. Okay, so a common pushback here is that object-oriented code can sometimes feel a little verbose. More lines of code to do the same thing. But this quote gets to a really crucial truth. You just can't judge the quality of code by how short it is. A super condensed one-liner might seem clever, but half the time it's completely unreadable, even to you, the very next day.
Exactly. There's this programming game called Code Golf, where the whole point is to solve a problem in the fewest characters possible. It's a fun puzzle for sure, but it is a terrible way to write professional software. The real goal isn't brevity, it's clarity and maintainability for the long run.
All right, so let's say we've decided to use an object. That opens up a whole new question. How do we handle its data in a smart and safe way? Well, that's where a really powerful tool called properties comes into play. You see, a core principle of good object-oriented design is something called encapsulation. It's a fancy word, but it just means protecting an object's internal data. You don't want other random parts of your code just reaching in and changing an object's state whenever they feel like it. That's how you get those really weird, unpredictable bugs. So how do you enforce that without making your code a total pain to use? Well, there's been a clear evolution in how we handle this. At first, you have direct access, but that's risky. Then you have the old way, which you see in a lot of other languages, with these clunky getter and setter methods for everything. But Python? Python gives us a much more elegant solution, the app property decorator. It lets you add all this protective logic behind the scenes while letting you keep the nice, clean syntax of direct access. It's the best of both worlds.
So what can you actually do with all that extra logic? Oh, so much. You can validate data to make sure a user doesn't enter an invalid email. You can cache a complex calculation so it only has to run once. You can implement specific access controls. You can even automatically log every time a value changes. Properties give you this incredible power, all hidden behind a really simple interface.
All right, next up is a principle that applies literally everywhere in coding, but it's something that object-oriented design helps solve beautifully. It's all about avoiding repetition and keeping your code nice and clean. Oh, we've all done it. You need a bit of code that's almost like another bit of code somewhere else, so you just highlight, copy, and paste. We call this copy-pasta programming, and while it feels like you're going fast in the moment, it is an absolute recipe for disaster down the line. And this is the result. I love this analogy because it's so true. You end up with this tangled, interconnected mess of code that's just impossible to follow. And if you need to fix a bug, guess what? You have to find and fix it in every single place you pasted that code. It becomes unmaintainable so fast. Duplicated code creates this extra mental tax. Every time you or another developer runs into it, you have to stop and ask these questions. It just slows down your comprehension and introduces a huge risk of error. You're basically forcing your future self to solve the same puzzle over and over and over again. The solution is the DRY principle. Don't repeat yourself. The moment you find yourself about to copy and paste logic, that should be a massive red flag. It's your sign that it's time to pull that logic out into a single, reusable place. And yeah, sometimes that's a function, but in many cases, it's a method on a well-designed class.
So why do we go through all this trouble, right? Why bother with properties and following the drive principle? It's all about the payoff. It's about building code that is designed to last.
And really, it all boils down to these two things. Readability simply means someone else, or you 6 months from now, can actually understand what the code does. And maintainability means you can fix bugs or add new features without bringing the entire system crashing down. These are the twin goals that should guide every single good developer. So let's put it all together in one simple framework. If you find you're focused purely on data, Python's built-in tools like lists and dictionaries are your best friend. If you're focused purely on behavior, just write a function. But the moment you realize your data and the behavior that uses it are fundamentally linked, that is your signal. It's time to build a class. Ultimately, if you only take one thing away from all of this, let it be this. Before you try to make your code clever or short or fast, you must first make it readable. Clarity is the absolute foundation of all good software.
And that leaves us with one final question to consider every single time you sit down to write code. Are you just solving the problem for this one moment, right now? Or are you building a solution that can be understood, adapted, and maintained for its entire lifetime? The choice you make really matters.